the name of one above all and with genuine regards and greetings to whomever watching, I am Seper Tehran, undergraduate student of nanotechnology, and today's topic is the application of nanotechnology in our daily lives. Well, our life has so many dimensions, innumerable actually, and nanotechnology could be applied to all of them, surprisingly. And today we're going to discuss about, well, a few of them. As you know, there are so many dimensions to our daily lives. Medical dimensions, constructions, housings, well, tools, equipments, you name it. We got it all. But how nanotechnology could be applied to so many of these dimensions and these fields, let's say, for example, medicine. For instance, we could use nanomaterials and nanotechnology for imaging, therapeutic applications, cancer therapy applications, theranostic applications, I don't know, you name it, antibacterial applications, improved drug delivery systems, improved cancer therapy, well, actually, you name it all, there is. For example, in imaging and in those terms, we use golden nanoparticles or quantum dots to refine and redefine the quality of imaging from cancer tumors. Well, as I've mentioned cancer, you already know the terminology, but what you might know is that cancer is already devastating so many lives around the globe, and there are so many scientists and researchers searching for the answer. But maybe the answers lied within nanotechnology, in the realm of nanoscale and nanomaterial. For example, we could use golden nanoparticles and clusters to make an improved imaging of different tissues. Or we could use the contrast of quantum dots to image the tumors and malignancies in our body. Now, what about drugs and medicines? Well, so many of you know that we have targeted drug delivery systems or enhanced drug absorptions, so many other different eras of drug and medicine in our body. Nanoparticles can detect cancer, can cure it, can make a drug delivery out of nowhere. How it works is it's simple. Whenever you have a headache, you're going to use a headache pill. But here's the thing, whenever you use the pill, that will affect all your bodies. Your bones, your vessels, your stomach, your blood, everywhere. But those affections will cause you side effects, unwanted side effects that you don't want it in your bones. Maybe it has even worse side effects than we imagined before. So what now is we can use those drugs to target wherever we want to cure. For example, we can use liposomes in order to encapsulate certain drugs, certain drug systems, for example, for curing the cancer. Well, for example, whenever you have a headache, you use a headache pill, of course, but that will affect integrity of your body, your whole part, your bones, your stomach, your blood, everywhere, but you only want it in your head. You only want to decrease the signs of headache. Well, that same principle applies to everywhere in our body. Well, whenever you got unfortunate and have a cancer tumor in your body, you want it to cancer, only the cancer to be cured, not everywhere of your body, because chemotherapeutical drugs are actually very, very, very hazardous. They have so many dangerous side effects that you don't want in your body, nauseous, nauseousness, dizziness, and so many other innumerable unwanted side effects. Well, you want to decrease it, right? The problem is within the targeted delivery system. For example, if you use a liposome to encapsulate the certain drugs, doxosome for example, you can cure your cancer without relying to whole your body. It doesn't affect whole your body, it only affects the cancer tumor. Well, how you ask, you say? That's another topic. Since we're on the topic of medicine, we might take a look to cosmetics and makeup chemicals. Well, as you know, one of them is UV protection. You put sunscreen on your screen to protect yourself against the ultraviolet of the sun. Since we're on the topic of medicine and drugs, you might take a look to cosmetics and makeup chemicals. Well, those chemicals, if integrated with nanomaterials and nanotechnology, will enhance the delivery, improve the texture, and also last-longing effects. Well, there are so many other dimensions such as anti-aging and nanoparticles-based pigments, but one of the most important and something that you may use in your daily life is sunscreen. You put sunscreen on your skin to protect yourself against the ultraviolet rays of sun, which may cause melanoma on your skin, which is a deadly term of cancer. But however, those sunscreens may contain minerals, zinc oxide for example, or titanium oxide, which can reflect light but in an enormous and innumerable photons, which will cause it to be seen as white. But if you use smaller particles, those light reflection will be decreased, and thus you won't have any white blurs on your skin, right? That's better. And also the protection will increase massively. In another example, we can go to agricultural industries. Well, as I've seen in this picture, we can use nanotechnology in different eras of agricultural targets. For example, in agriculture, we need better soil, we need better plants, we need to edit them genes, we need fertilizers, we need compostings. Well, nanotechnology is obviously could be applied and is applied in so many eras of these mentioned topics. One of them is plant growing, the other one is stress tolerance, nanosensors. Well, I will make a brief introduction to any of them. For example, nanosensors could be used to monitor the growth of the plant and also biochemicals in it to ensure the efficiency of the growing. Or nanopesticides could be used to make them less toxic for us and also defect the insects. You know, we don't need insects in our plants, right? And there are so many actually different eras. For example, nanobiotechnology is the era of integrating biology with nanomaterials and nanoscale properties, which will indeed cause a significant and extraordinary properties and arose in sciences. Well, you ask how? That's simple. We can edit the genes. For example, if a plant grows too much, we don't want it to grow, we can cut out those genes and then voila. And then voila, it won't grow too much. That's the desired property. It could be applied in so many different eras. Now we're on to food and plant. Let's go to the food industry. What nanomaterials could do in there? Well, the first thing is packaging, as we could assume. Packaging is so important in nanomaterials applied in food industry because food may contain and be contaminant to bacteria and other different organoids that we don't want it to be contaminated with. So what do we do is we make them antibacterial as much as it's possible and with less toxicity for our bodies. This is very desired because in packaging we could use, say, golden or copper or even aluminum or, as you know, silver nanoparticles in order to make them antibacterial. There are so many other different eras in food industry. For example, the formulation of the same food we're eating, the delivery of that, the nanobiotech for gene editing, or monitoring, censoring, so many other dimensions. As I've mentioned in the first slide, there are innumerable dimensions in our early daily life, and nanomaterials could be applied in any of them. You just need to think deeper. In another topic, electronics is in the table. Well, you don't need me to say how much nanotechnology could be important in electronics because we already deal with so incredibly small creatures in this era. lithography could help us to make better integrated chips. We could use surface area, enormous specific surface areas, to integrate and synthesize better supercapacitors to capacitate more electricity as we desired. Better batteries, better chips, better diodes, better LEDs, everything could be improved with nanotechnology and nanomaterial, especially in electronics. The other terms are nanotechnology could be used to increase the durability of electronic components. Diodes, transistors, LEDs, we could use it to make smaller components, improved electrical conductivity, improved properties in photoelectronic devices, and etc. and etc. Nanotechnology is indeed everywhere. In another example, we could use nanotechnology in construction, in our housing, in our daily lives, in architecture. Now that I mentioned the construction business and housing, well, you might ask how? Why nanomaterials should be applied in these industries? Well, it's because of those topics. For example, enhanced strength, improved durability, energy efficiency, self-charging surfaces, self-cleaning surfaces, thermal insulation, reduced weight, fire resistance, etc., etc. How do they use nanotechnology in order to grant these purposes and targets in the construction industry? Well, it depends on the property of that material itself. For example, enhanced strength could be achieved by adding some strong materials to our concretes. Take this concrete block, for example. Well, it may seem like normal concrete, but if you add an additive, for example, carbon nanomaterials, which are famous to be so strong, so durable, and so flexible, into the matrix of this concrete, then you have some sort of, component named composite. Well, these composites are so stronger than their normal behavior. We can use it in our daily routine, in our tilings, in our ceilings, in the concrete that makes the very walls of your homes and houses. Or in another example, we could use self-cleaning surfaces. They are achieved by superhydrophobic and superhydrophilic surfaces that made from lithography, from silicon oxide, from titanium oxide, different materials, different methods. But the purpose and the goal is the same, to make a surface incredibly, unbelievably, and extraordinarily endurable, to get wet or vice versa, to be not wetted. That's the mechanism to clean a surface. Well, there are other different properties involved in these topics, for example, photocatalytic properties, but I'm not going to go into there. You could read more in the description below and in the sources. Now, since we're on the topic of construction, civil engineering, architecture, etc., we could use another engineering topic known as petroleum industry. Well, you don't need me to remind you how important petroleum industry and oil is in our daily routine. Well, since it's the main energy resource for mankind, at least in 2 centuries right now. But what is the importance of integrating nanomaterials and nanotechnology in general with the petroleum industry? Well, as you can see in the topics, enhanced oil recovery, improved drilling fluids, corrosion protection, catalytic efficiencies. There are so many of the topics that belong actually to the properties of those nanomaterials that are used in these industries. For example, this nanomaterial exactly in this jar is actually a polymer for isomerization in the oil industry. But you could use so many different materials for different purposes. Anti-corrosion materials is a good example, used in petroleum industry or cracking material in petroleum industry. Well, corrosion is actually very damaging phenomena in the industries. It causes so many money lost in simple term, and preventing corrosion is very important, which could be done easily and cheaply with nanomaterials. In another example, let's go to the area of filtration. This field is very important in our daily life because the air we breathe, the water we drink, The drugs we use, the food, everything should be filtered because in order to not harm us in the simple term. But why is it so important? For instance, the water you drink is having many, for example, the water you drink has many resources depending on the geolocation of you. But we use waters everywhere. We need water in our daily life, and water is present where life is present. But here's the simple trick. Water could be contaminated with different chemicals, with different microbes and microorganisms, with different pollutions. We don't want polluted air, we don't want polluted waters, and we need to filter them. So what now is we could use nanomaterials as a filtration system in water supplies and air supplies, and so many other different chemicals in order to purify them. Now, as you see in the picture, starting with a microfiltration and then an ultrafiltration, lastly nanofiltration gives you the clean water, and then you reverse osmosis, and then voila, you get the pure water to drink. But every layer, every proper layer should be designed properly and respectively with the property you're aiming for. For example, if you want to reduce the redundant chemicals, you can't use filters with big folds and big holes in it, because it's simple. The chemicals can actually go through those holes, but bacteria, being much bigger than those holes, can't. So the first filtration has bigger pores and bigger porosities. But if you reduce the hole size and if you increase the porosity of the material, what happens is you could filter your chemicals in the water or in the air. So important for our daily life, right? We can't live without filtration. How about automotives? Well, if you're a fan of cars and automobiles, you'd realize that nanotechnology is actually applicable everywhere in a car. Every car component, tires, or glass windows, sheets used in coloring the cars, so many things that could be applied by nanomaterials in order to get and grant so many different targets and purposes. In one target, we could manage the engine's combustion with nanomaterials. The other one is to make a cleaner surface, superhydrophobic surfaces that get no wetting on them, and thus you won't have any moisture on your car. Or even catalytic conversions in order to filter the exhaustion from your car's engine in order to reduce the pollution of atmosphere, and etc., and etc. So nanotechnology could be applied in very different and variable areas in car industry. Well, now we mentioned car, the best topic next is the energy industry. Well, it's so important because energy is actually one of the most important dimensions in our life. Everybody thinks about energy, everybody needs energy, and everybody consumes energy. But how do we get that energy and where do we get it from? As I've mentioned, we get it from petroleum, oil industry, we can get it from coal, sun, wind, water, rivers, basically anything. Nuclear fusions, nuclear fissions. Mankind had sorted its way in order to grant every resource as an energy resource. But here's the problem. The efficiency is low in so many of these areas. The efficiency of photoelectrical interactions are lower, actually so much lower than oil industry. Well, what to do? We enhance it, we improve it, we work on it, we develop it. But how to develop material? You know the answer already, right? Well, we could use quantum dots in solar cells in order to grant higher efficiencies for them, or perovskite cells. We can use nanocomposites in our wind turbines to reduce the friction and actually improve the efficiency. Well, nanoscaled materials could be applied in the vast era of energy industry. Take for instance graphene. Graphene is an eccentric material with extraordinary properties. Its strength is higher than you anticipate, it's endurable, electrical conductivity is enhanced, and so many other properties. It is eccentric indeed. We can use graphene in supercapacitors because of their high ratio of their surface area to their volume, or as you know it from previous sessions, specific surface area. The specific surface area of a graphene is so much more than the bulk form of its carbon atoms, so thus we have high surface area, ratios to volume, and also good electrical conductivity. That means we could use graphene in order to make better electrodes in the supercapacitors or even batteries. How you ask is, if you're a sports fan, it doesn't matter what sport you're a fan of, it could be basketball, football, volleyball, it could be hockey, tennis, well, you name it, you're the fan of it. But if you're a sports fan, you know we use different equipments in various different fields of sport and athleticism. Well, luckily, those materials, those equipments and tools could actually be integrated with nanomaterials in order to enhance their properties. Well, for instance, we can make better tennis rackets, endurable, flexible, better aiming, better shoots. Voila, better score for the targeting athlete. Or we could use a textile that can't get bacteria on it, antibacterial fabrics. It is very important in this field. Soccer players can use those fabrics in their clothing so that they won't get so hot in the field. Well, that's right. You won't get wetty, you won't get sweaty. Actually, that's because they are super hydrophobic fabrics. And as you can see in the picture, super hydrophobic fabrics can't get wet. It's because of their very own properties that were mentioned, which we mimic from the biotechnological lotus leaves in the nature. Well, these imitations helps us in order to grant better grasp in the nanotechnology field and also in order to apply it in our daily life. Actually, there are innumerable topics that nanotechnology is integrated with in industry, in biotechnology, and in many other fields and areas. But since we have lack of time, we cannot point them out, all of them. So be creative, be curious, and search and investigate for yourself. And maybe there's an era that can be integrated with nanotechnology and is not yet to be discovered. So you are the guy to make the creativity. There are so many rooms and plenty of different eras to be creative in, especially if you integrate it with nanotechnology. And as always, if you had any further questions, you could find my email in the picture. And thank you very much for your time and for your patience. Goodbye.